This is another example for area and volume. So on this example, we're going to consider the region bounded by y equals cosine x equals 0, y equals 0 on the interval 0 to pi over 2. Okay, so y equals cosine x starts, well, we think of it as starting at 0, 1, and it goes down and has an x-intercept at pi over 2. If this region's bounded by that, x equals 0, which is the y-axis, and y equals 0, which is the x-axis, we're just concerned about this part in the first quadrant. We know this is at 1. We know that the x-intercept is at pi over 2. We can use a rectangle that goes either way. I'm going to choose a vertical rectangle with base dx. If we chose a horizontal rectangle, we would want to solve for x, which would mean we'd need to use inverse trig, and I'd like to avoid that. So because it's dx, we're going to have everything solved for in terms of y. I'm sorry, in terms of x, but we're going to solve for y. And so we're just going to label that as y equals cosine x. That's it for getting the region set up. Now we're going to do several problems. So number 1, we're going to say set up an integral used to find the volume of the region when the region is revolved about y equals -3. Number 2 is going to be about the x-axis. And number 3 is going to be about y equals 2. Please pause the video, try all 3 of these, and then check them with me in just a few minutes. Okay, y equals -3 is down here somewhere. Because we think of the rectangle as being perpendicular, we use the disk washer method. Big R is then the distance from the farther end of the rectangle to the line. That's cosine x minus -3, which is cosine of x, and then plus 3. It's important that the plus 3 is not within the cosine. Small r is the distance from the closer end of the rectangle to the line. That's the distance from there to there. That's a vertical distance. Well, the top y then is actually always 0 because it's always along the x-axis. This bottom y is -3, and so we get a constant small r of 3. Volume then is pi times the integral cosine x plus 3 squared minus 3 squared times dx from 0 to pi over 2. Okay, for the x-axis, that's also a line under the region. It's just obviously drawn on the diagram already. Capital R is the distance from the farther end of the rectangle to the x-axis. That's the top y, which is cosine x, minus the bottom y, which is 0. Small r is the distance from the closer end of the rectangle to the x-axis, but the closer end of the rectangle is on the x-axis. So that is 0 minus 0, which is just 0. That means that we can set this up as pi times the integral from 0 to pi over 2 of cosine x squared minus 0 squared dx. It would be much simpler if we chose to go ahead and rewrite that as pi times the integral 0 to pi over 2 of cosine squared x dx. For problem 3, y equals 2 is a horizontal line above the region. So we look at the line as being up here. Again, disk washer method because we think of the rectangle as being perpendicular to the line. Big R is the distance from the line to the farther away end of the rectangle. That's 2 minus 0, which is 2. Small r is the distance from the line to the closer end of the rectangle. That's 2 minus cosine x. Volume then is pi times the integral from 0 to pi over 2 of 2 squared minus, let's make that a little neater, 2 squared minus the quantity 2 minus cosine x squared dx. let's have you pause the video and try the next 4 problems, and then we'll work them quickly together. So x equals 4, x equals -2, the y-axis, and then the last question will be to find the area of the region. Okay, so for these last 4 problems, we're talking about vertical lines, which we think of as being parallel to the rectangle that we've got. X equals 4 is to the right of the region. We use the shell method. R is the distance from the line we're revolving around to the rectangle. That's 4 minus x. H of x is the height of the rectangle. That's cosine x minus 0, which is cosine x. Volume then is 2 pi rh. So we say 2 pi times the integral 4 minus x times cosine x times dx from 0 to pi over 2. For x equals -2, we've got a vertical line to the left of the region. Again, the shell method. R of x is the distance from the line to the rectangle. That's x minus -2, which is x plus 2. The height is the top y minus the bottom y. That's cosine x minus 0, which is cosine x. Volume then is 2 pi times the integral from 0 to pi over 2 of x plus 2 cosine x dx. For the y-axis, obviously we're looking at the y-axis this time, we're talking, let's put the y-axis back in. We're talking about a vertical line that we think of as being parallel to the line that we're talking about. So we're using the shell method again. R is the distance from the rectangle to the line. That's x minus 0, which is x. H is the height of the rectangle. That's cosine x minus 0, which is cosine x. Volume then is 2 pi rh. So it's 2 pi times the integral of x cosine x dx from 0 to pi over 2. The area of the region is just the integral of the height times dx. The height is cosine x. So area is the integral of cosine x dx from 0 to pi over 2. This video has been quicker than the other problems. If you do have any questions, feel free to contact me. But also look back at the videos prior to this on area volume. There are more examples worked more slowly. There are also a ton of examples on the homework. Thanks for watching this video.